Welcome to the SNN Network Canada virtual event. I'd like to introduce our next presenter, Andrew Scappell, President and CEO of Edgewater Wireless. Andrew, the floor is yours.
Excellent, thank you. I see a number of familiar names here and a number of new people. Thank you very much for joining the Edgewater Wireless presentation. At Edgewater Wireless, we make Wi-Fi better. We're a highly disruptive next generation Wi-Fi technology. We are, I will let you read the fine print on your own time. Globally, there has been a massive shift to work from home with COVID. And essentially, work from home has resulted in an enormous increase in the number of devices connected to Wi-Fi. There's over 4 billion Wi-Fi devices added over the last 12 months, and networks are seeing a 60% spike in at-home traffic. You know, significant amount of that traffic, as I said, is over Wi-Fi. Yet, Wi-Fi generates 40% of customer care calls at major service providers. It's a significant challenge for these service providers whose customers rely on Wi-Fi. Now, what if we could deliver a 10x performance improvement or more? Let's talk a little bit about the problem, just to level set for everyone. Wi-Fi has been essentially unchanged since 1999. It's been based on a single channel radio architecture, which is a lot like a single lane road. And it works great when you have one device. But like a single lane road, when you pile a lot of traffic or vehicles on that lane, it slows down and everyone gets bogged down by the traffic. And with Wi-Fi, this is largely due to the devices contending for access on that single channel. Each time they contend with that access, collisions increase, and latency is the net result. All of the devices slow down, throughput performance slows down, and the net result is people pick up the phone and they call their service provider to complain. Well, at Edgewater Wireless, we looked at the problem and we said, how do you fix a traffic congestion problem? Well, we invented, built, and patented the world's first multi-lane highway for Wi-Fi. It's something that we call in-band spectrum slicing, and it gives service providers a way to optimize the capacity of their networks by spreading the devices over multiple lanes and reducing that contention or the congestion on each of those lanes. And the net result is dramatically reduced latency, reduced contention, improved performance. And for a service provider, it means fewer customer care calls and more opportunities for monetization. Now, let's take a look at that in the real world and find out what that means. Earlier this year, we completed a proof of concept with a major tier 1 service provider, where we looked at 6 million devices in over 750,000 homes. So very significant sample size, and each one of those homes had cutting edge access point, Wi-Fi 5 access point. And the average number of those homes had about 8 devices. So starting to see some contention. Now, what we realized was the performance that's indicated on the side of the box, the gigabit throughputs and the big gold letters that you see when you buy an access point. The performance simply wasn't being delivered because of the number of devices and the interference in the home. So we said, what if you implement spectrum slicing? our approach of a multi-lane highway in those homes. Well, in about 75% of those homes, we saw anywhere from a 7 to 18 times performance gain in spectrum slicing. Now, obviously, these are very dramatic, significant performance gains in the home. And we got the attention of the service provider and the community, and we were able to progress from the proof of concept into a pilot, which we completed a few short weeks ago. And that pilot, we saw very similar results in the real world using Edgewater's beta silicon solution. So we'll talk a little bit more about that further on in the presentation. Key thing, how do we go to market? How do we monetize this technology of ours? Really, a couple of main areas in which we monetize. At the core of what we do, we're a fabless semiconductor company. We design our own silicon, our own spectrum slicing silicon, which can be used by large-scale OEMs and service providers to power gateways, residential access points, televisions, etc. Now, at the core of what we do, we've got over 25 patents giving us a lock on the spectrum slicing approach. Our core is really about interference mitigation, which allows there to be more lanes used. Now, on the IP side, that opens us up to licensing opportunities with other silicon providers. Key customer, our first customer in the licensing space was really Apple. Now, on the silicon side, we've had an early design win with Kroger Corporation. And as we've moved through and built those proof points outside of the residential space, outside of the enterprise space and the large venue space, we've moved into the residential space. So we've significantly demonstrated there's an increased and large market opportunity for spectrum slicing. Now, from a corporate perspective, we've had a very strong strategic focus in 2021 and bleeding into 2022. Key milestones for us are proof of concept, commercial pilot, and silicon partnerships and alliances. Now, the proof of concept and pipeline expansion, really focusing in on tier one service providers who've demonstrated and displayed a strong and genuine interest in participating in future POCs. So really understanding more about the residential Wi-Fi market. Now, this year we completed our first POC with a major service provider. We demonstrated really significant results, reaching into the network and understanding what's happening in the real world. Not the marketing number, not the performance number coming from, coming out of a Faraday chamber or a controlled RF environment, but what's really going on in the home. That was a major step for the company to really understand the overall market opportunity for spectrum slicing. Now, we're continuing to build a robust pipeline of tier one service provider opportunities for POCs. Now, the next major step for us was our recently completed pilot project. This was the top priority for the company and was to progress with that tier one service provider into something that's real world, really taking our semiconductor solution and putting it through our paces. And this isn't, us testing it. This is a tier one service provider putting us through the paces of what they see in the home, all done by an independent test company. Now, we demonstrated superior results in that pilot. Now, one of the key things to come out of that pilot is not only do we see that performance gain, and those multiples on performance over legacy single-channel Wi-Fi that all other silicon providers focus on, we saw a 50% reduction in latency. Now, latency is one of the key causes of disruption in Wi-Fi. It's really the base of those customer care calls. It causes your pixelated videos. It causes slowdowns in your gaming experience. And it is really one of the biggest challenges. Now, that latency number isn't something that we at Edgewater set out to do in the pilot. It's something that the test house and the service provider identified as a very strong part of our value proposition. Now, with these market validations and that continuing market validation of what we're doing and how significant and relevant it is to a large portion of the market, it's important for us to build silicon partnerships and alliances with several potential silicon partners to strengthen and our move to capture that volume market for spectrum slicing silicon. Now, many of you are acutely aware of the global disruption in the semiconductor supply lines, impacting not only semiconductor companies like Edgewater, Intel, Qualcomm, but a diverse set of companies that rely on semiconductors. As diverse as automobile companies like Ford and Tesla, that is a major, major challenge. So for a company the size of Edgewater, it is essential that we build the right network of silicon partnerships and alliances to bring our silicon to market. Now, earlier this year, we announced one of our key partnerships with CMC Microsystems. CMC Microsystems brings an ecosystem that is very important and helpful in accelerating the commercialization of our silicon. Now, look for continued updates on silicon partnerships and alliances as we move forward into 2022, and updates on the commercial front following the successful pilot and some additional POCs. Now, Edgewater has really positioned ourselves as a thought leader in Wi-Fi. Not today's Wi-Fi or the legacy single-channel approach, but where Wi-Fi needs to go to deal with the enormous number of devices that we all have in our homes. Whether it's your laptops and your tablets, your refrigerator, light bulbs, television, everything is Wi-Fi. And the legacy architecture simply was not designed to deal with the enormous number of devices. Now, we've positioned ourselves with leading industry bodies like the Wireless Broadband Alliance, or through our relationship with Cable Labs and their accelerator program, UpRamp. It's really allowed us to drive groundbreaking applications which highlight the need for spectrum slicing or more channel capacity. And that's, things like in the 5G space with the WBA and Nokia and Comcast, or broadcast Wi-Fi with the British Broadcasting Corporation, or even the dual-channel Wi-Fi standard, which we co-innovated with Cable Labs. Now, we're Edgewater Wireless. We trade as YFI on the TSX-V, and we make Wi-Fi better. We've got over 25 patents in the core of our technology, and there's been over $60 million invested in our core technology. We're entrenched in the cable industry, in the service provider space, and we have a number of key early-stage customers, whether service providers like the 5th largest cable operator, Mediacom, or Kroger Corporation. A quick snapshot of our cap table before we shift over to the questions. We've had a number of questions come in I think we'll shift over there. Now, one of the first questions is really about the competitive landscape. Can you talk about the competitive landscape, and do you have other competitors, or would other companies be more likely to be clients and partners? Perhaps we can put up the slide of comparables here. So at Edgewater, we've taken a highly differentiated approach to what is a ubiquitous market. Our competitors, whether it's Broadcom, Intel, Qualcomm, MediaTek, etc., have all taken an approach based on a single channel radio. Our differentiated approach is really to offer more physical channels for capacity. So it's really about providing the next generation of capacity and performance. Now, a number of these competitors are potential licensing partners for us as they move to the next generation of silicon and move to really address the performance needs in a large portion of the market. Now, the home, it really does need to, or we firmly believe that the industry needs to shift towards something that delivers more capacity and performance, and that is spectrum slicing. Can you shed some light on the total addressable market and what's available to us and what's our path to market? Now, the global Wi-Fi chipset market is about $25.2 billion by 2026. So it's a significant market size for silicon. And we look at, in terms of our TAM, or total addressable market, we look at roughly 50% of that, which is $12.6 billion, being focused mainly on larger devices. Larger devices like gateways, like access points, repeaters, televisions, those things that require more bandwidth. We're not really looking at things like a light bulb or an IoT sensor or even a handset at this point in time. So our addressable market is about $12.6 billion. Now, in terms of our path to market and our commercialization strategy, we're laser focused on the service provider Wi-Fi space. And that is working with tier one service providers, such as, could be someone like a Comcast, Charter, Liberty, or even telcos like AT&T or Verizon, many of whom design and, in quotes, manufacture their own access point. Our strategy is to get designed into their residential gateways. And that's really why the proof of concept and the pilot that we completed a few short weeks ago are so important for our go-forward strategy. Now, outside of those direct semiconductor customers, we do have the potential to license our expertise and our IP to other silicon providers to bring spectrum slicing to market. And another question here, can you explain the difference between a single lane and a multi-lane approach again? Many folks ask this question. Isn't this MIMO? Isn't this Wi-Fi 6 or whatnot? But what we're talking about, MIMO is taking a single channel and distributing the transmission and receiving over multiple antennas. So it is not spectrum slicing or multi-channel. It's simply a single channel. What we're talking about is taking that same single channel and replicating it multiple times through a single radio. So it gives service providers a real way to use that additional physical capacity to deal with the number of devices that are out there. Next question. If you get a 10 to 15 million chip order out of a tier 1 pilot, how are you planning to deliver that? That's an excellent question. When working with large service providers, it is critical to show a robust supply line and the capability to deliver. So a key part of our strategy in doing that is to build those alliances and partnerships within the semiconductor space. They really allow an early stage, smaller player like Edgewater Wireless to punch above our weight. Now, in addition to those partnerships and alliances to bring our silicon to scale, there is also the opportunity for licensing some of our core IP. Our preferred approach is to supply silicon. Another question here. You've talked about the strong pilot results. Can you provide more insight to the level of testing performed and the real-world capability? That's a long question. Now, in terms of the pilot or the recent testing results that were announced, it's really important to note that this testing wasn't done in a Faraday chamber, right, which is a closed RF environment that really allows silicon vendors like ourselves to show the highest throughput or the highest burst rate throughput. Now, the reality is in your home, you just don't see those results. So with this pilot, we worked with the tier 1 service provider and a third-party independent test house who essentially have a full-scale house built within a warehouse, where we deployed our silicon within one of our access points. It was a 6-channel access point. So we were showing 3 channels in 2.4 and initially 3 channels in 5 gigahertz. And we took those devices, which were arranged throughout the home, and compared them to a standard, single channel in 2.4 and a single channel in 5 gigahertz to 6 channels. And surprise, more channels delivers better performance just by reducing that contention between those devices. Now, a couple of key things that are worth highlighting in that residential pilot is when you move devices further away from the access point, performance declines. Now, when you're sharing that on a single channel architecture, a legacy single channel architecture, whether it's in Intel, Broadcom, Qualcomm, whoever the chipset vendor is, the net result is that device slows down every other device on that network. And by implementing multi-channel or spectrum splicing, we can spread those devices over multiple channels and really improve the aggregate performance of that household. So very extensive testing was done, different distances, different types of devices, and to make matters even more challenging, the service provider introduced interference, very similar to what we saw in those 750,000 homes. We said, turn on the interference, make this as real as possible, put us through our paces, and that's where we perform best with spectrum slicing. Next question, again, a little bit more technical. Does a dual band radio, with a radio in 2.4 and 5 gigahertz, solve the Wi-Fi traffic issue? Why is spectrum splicing better? Interesting question. Like this is really what we proved out in both the proof of concept and the pilot, that it's simply not enough capacity to do those dual band radios in the home. Now, we're even seeing some access points that they might say they're triple radio. They still only have one radio in 2.4 gigahertz, and with most service providers, they limit the channel width to a 20 megahertz wide channel in 2.4 gigahertz, which means you run out of capacity very quickly. With our solution, we were demonstrating, 3-channel, 20 megahertz wide channels in 2.4, and the same in 5 gigahertz. Now, some of the newer access points will show 3 radios, 2 in 5 gigahertz, one at the bottom of the band, one at the top of the band, and an expensive filter in between the two of them. Now, that really limits the configuration and the capacity available for service providers. Let's see, there seem to be a few more questions here. So spectrum slicing, just to go back to the 2 or 3 radio question, spectrum slicing is taking each ISM band and delivering more radios in each band. So for the service provider, it gives a massive increase in the capacity and the flexibility. Now, the last slide, again, is a bit more of a technical snapshot of what's happening with spectrum slicing. On the left-hand side, it shows a single-channel radio, with 802.11 AC or even AX. It starts out at 160 meg wide channel. If that isn't available, it backs off to an 80, to a 40, to a 20. And all of those devices have to share that narrower channel or that slower channel and deal with, and this is due to, attenuation, interference, all of the things that you see within the home, which are replicated in that commercial pilot. Now, in terms of the spectrum slicing approach, rather than being limited to a single wide channel, we take that same spectrum, that same airspace, and we slice it up, and we can do within our IP and our product strategy, we can do 2 80 meg wide channels, or a number of 40 meg wide channels, all the way down to 20 meg wide channels, which allows us to deal with interference much, much more effectively while spreading that client load and over multiple physical channels and reducing the contention. Hopefully that answers that fairly technical question. One other question here that I think we can fit in. How do you plan to fund your next level of growth? Good question. We are an early stage emerging technology play, which means you're always on the hunt for opportunities to effectively fund the company and to generate and create shareholder value in doing so. 2 main methods of doing that are equity or debt. Our preferred approach is to work with strategic partners and pursue exercises that are less dilutive. And I think one last question: what protection time does Edgewater have left on its core patents? The beauty of what we've done with the patent portfolio is we've developed a family of patents, which we, as part of our strategy, and in addition to that, we have worked through on a number of continuations and extensions of that patent portfolio. So with over 25 patents in the portfolio and continuing to grow that environment, it gives us significant time on the core patents. And again, keep in mind, we're not about one patent. We're about the family and the ecosystem of patents that are built around the core technology that allow us to implement spectrum slicing. I believe we've run out of time, but I appreciate everyone for joining the presentation. Thank you very much, and I'll now hand the presentation back to the moderator. If the mic is still open, I think we have a few more minutes to answer some late arriving questions. What precisely does a commercial pilot meaning versus the residential POC mean? A POC is a proof of concept. That is largely a data-driven, mathematical exercise, whereas a pilot is actually taking our silicon and putting it through its paces. So they're very different exercises, and that's why it's so impressive that we were able to deliver or mirror the results of the POC in the pilot. The POC does two things, right? It demonstrates the need for our technology in the residential Wi-Fi market, right, which is a significant and large market opportunity. And then the pilot actually shows that we can do what we can do. And I think that's it for the questions and the time. Thank you very much for joining the presentation.
This does conclude today's presentation. Thank you for tuning in.